Insurance Insights is a presentation of the Institute's Griffith Insurance Education Foundation, whose mission is to empower public policymakers through a greater understanding of insurance and risk management. Deeply committed to objectivity, all Griffith Foundation programming is strictly instructional in nature and does not support a position on any issues.
Innovative approaches to resilience were introduced in Alabama several years ago with the goal of enhancing the resilience of homes prone to severe weather events. Academic efforts have been underway to determine the effectiveness of these innovative initiatives by reviewing and analyzing relevant data. Dr. Lars Powell of the University of Alabama, the director of the Center for Risk and Insurance Research, has led these academic efforts, and he joins me now. Lars, for those public policymakers around the country who may be unfamiliar with the innovative resilience initiatives in Alabama, could you first provide a very brief overview before we talk about your recently released findings regarding the efficacy of these initiatives?
Thanks for having me on. It's always great to talk with Griffith and always great to talk about resilience in Alabama. So the program in Alabama, or the approach is three-pronged, and the specific elements, we start with the Strengthen Alabama Homes Grant Program. And that created sort of a supply of fortified houses. You need to have a number of contractors knowledgeable and able to build the fortified houses to implement the mitigation before it can really be widespread. And so by making this grant program, which has now spent $85 million and created, I believe, more than 8,700 fortified designations, primarily the roof designation in Alabama. That creates sort of a critical mass of contractors that can build these houses. After that, we've got the mitigation discounts. So these are incentives for both for homeowners and contractors, things to get people to choose to mitigate their home, to build fortified, to re-roof fortified. These mitigation discounts make it obviously a good economic decision for consumers to build fortified. And the last thing is the fortified roof endorsement. So every insurance company in Alabama has to offer at an adequate premium this fortified endorsement, which rebuilds a home to the fortified roof standard, the fortified roof designation, and that keeps us from rebuilding the same junk that always happens. You have a hurricane, and all of a sudden you've got to rebuild 20 or 30,000 houses. We don't have time to change what we're doing now. We've just got to rebuild these so people can move back in. But if you've got people conditioned to know that they need to rebuild fortified and you have the resources to do that, then we think that's as important as the mitigation discounts and the Strengthen Alabama Homes program, to not just hurry up and rebuild a bunch of junk.
Lars, thank you very much. Appreciate the overview, and a quick follow-up for you, if I may. For folks who may be unfamiliar with the fortified program, the fortified standards, just in a nutshell, could you sort of quickly provide an overview there?
Yes. So the fortified houses don't blow over in the wind. I mean, ultimately they would if the wind is strong enough, just like anything else would. But for most of what any home is ever going to face at the coast, the fortified house, the fortified roof is one that is attached to the walls of the house. The decking of the roof is attached with better fasteners, these ring shank nails. The roof deck is taped at the seams so that water can't get in when the shingles come off. And then from there, it just gets stronger to impact resistant openings like the garage door, the windows, and doors to the home are impact resistant, so it can't be. Once wind gets through a window or something, it makes it a lot easier to blow the roof off the house. And once water gets in the house, your house becomes a bucket and it fills up and everything gets ruined. So you've got this, and then the final stage, the gold fortified, is going to have the walls connected to the ground to make this complete envelope of the house that is resilient to wind up to pretty fast speeds, faster speeds than you're going to see in most hurricanes. And that's the basics of what it is. But the general idea is that hurricanes are not an insurance problem. Insurance is where you feel the pain of a hurricane unless you build your house to withstand a hurricane. And it turns out that it's a lot less expensive to build better houses than it is to capitalize an insurance industry that can pay for large catastrophes.
Understood, Lars. And so let's delve a little deeper. You've been evaluating the efficacy of this program. You just touched upon it in the last sentence or so that you shared there. I would imagine that that's been a multifaceted approach to sort of evaluate how effective this initiative has been. How did you and your colleagues go about this analysis, and what have you found?
So we waded into this analysis with a huge grin. This is like for an insurance data nerd. This is one of the funnest things, or one of the most interesting projects you can possibly have. And what was nice about it, I know that there's been other studies like this. To my knowledge, I haven't seen them, and I've asked to see them, so I know that they require a non-disclosure agreement to be seen. So it was some open field work. We got to start with first principles, which again, as a scientist, is the most fun you can have, but also the most good you can do. So we kind of started with first principles of how do we compare a fortified house to what we just decided to call a conventional house, one that was built to some other standard other than fortified, sometime before the fortified houses came along or even after. And so we started just by comparing those statistically in the best ways that we could. And we iterated back and forth with feedback from other experts. And we wound up with several different approaches to comparing, because different constituencies care about different things. The insurance companies have to pay for all the losses that happen, but the fortified system is not made to mitigate all of the losses that can happen. For example, 46% of the losses in Hurricane Sally were from trees falling on houses. And it's really, really hard to build a house that just stands up to a tree falling on it. It's much less expensive to cut down the trees that can fall on your house. And that's kind of a thorny issue, because cutting down trees is not what a lot of homeowners want to do. Nonetheless, we look at these things as what happens when you include the tree fall claims that the insurance companies still have to pay for. What happens if you exclude those? As you get a much tighter estimate, a much more accurate estimate of how well fortified actually works. And then we can also compare across the levels of fortified between the roof, which used to be called bronze. A lot of people are familiar with fortified bronze, silver, gold. We didn't have enough fortified silver designations to add into the analysis, but we compared both the fortified roof and the fortified gold to conventional houses. And we come up with a few different ways to do that gets to, each one gets closer to an all else equal scenario. So being able to control for things other than how the home was built.
Thank you, Lars. Very helpful. And so, please, we're eager to hear hear from you about the findings. What did you find here?
We find that it works, that fortified works, and some specifics, kind of all else equal. A fortified home in Hurricane Sally is 75% less likely to have any claim at all. So it's going to reduce claim frequency in a strong Category 2 hurricane with winds up to the highest recorded wind speed we found was 109 knots, which is about 130 something miles an hour, pretty fast. And what we found was a 75% reduction in claim frequency. And then when there was a claim, it was at least 20% smaller. Now, again, these kind of all else equal are taking out the tree fall claims, but it turns out the tree fall claims were about the size of the average claim. So there's not a lot of bias coming from that. The average tree fall claim on a house was about $20,000, as was the average claim on a house was about $20,000. So it takes out some of the frequency. The severity wasn't really affected by that. And let's see, we had a few other things that were pretty nifty about the fortified houses. One, and actually, I don't want to bog you down because we're going to release the whole study, and hopefully by the time this plays, we will have released it and everyone can go and read it. But the thing that I was struck by, and I thought was the most important, was that our results very closely, very accurately followed the predicted results of the engineers that came up with the fortified program. They said for a fortified roof, you wouldn't expect to see any claims until you get above the wind speeds required for structural damage. So most of the losses happen in a hurricane with wind speed below about 120 miles per hour or 104 nautical miles per hour. That once you get above that, you start seeing structural damage to houses. Below that, what you see is shingles coming off of the roof. And if you've got your roof deck, the seams of it are taped, as in a fortified roof, then you don't get any water in the house, and you're really excluding the largest part of damage from any hurricane is this water intrusion that happens after the shingles come off of your house. So in the cases where you see wind speed exceeding that, you do start to see a little bit of structural damage on the fortified roof, but you don't see that in the fortified gold. The fortified gold held up really well to the higher wind speeds, and when there's not trees falling on those houses, they perform really, really well. That you don't see much claim frequency at all.
Lars, this is thank you for sharing these findings with us. Big picture, exciting stuff to be sure. No doubt a number of members of our audience, both state lawmakers and insurance regulators, will be eager to read more and learn more about not only this resilience initiative, but about your analysis and the findings. Where can folks go if they want to delve a bit deeper here?
People can read it. It will be on our website, and then there will be links from the Department of Insurance website and hopefully a lot of other places. I hope you'll have a link to it on the Griffith Foundation website, because what could be more exciting than insurance data analysis?
Indeed. With that, Lars Powell, a parting question for you, if I may. As you look ahead, how do you foresee this innovative initiative perhaps serving as a springboard to additional innovation and efforts focused on advancing resilience? What might the future hold? What can we learn here?
Sure. The thing that we hear most often from insurance carriers that aren't excited about fortified or aren't excited about loss mitigation is they say, well, we've seen it in the lab and we know what the expected performance is, but we really don't know if it works in a storm. So now what we're showing is that, yes, it works in a storm, and it works almost exactly like we expected in the lab, as long as you're addressing some of these other issues, like is there a large pine tree 40 feet away from your house? That's, it's really not designed to address that, but everything that it's supposed to do, it does very well, and it does almost exactly the way that the engineers at the IBHS lab expected it.
Dr. Lars Powell of the University of Alabama, the director of the Center for Risk and Insurance Research, thanks for being with us. We really appreciate it.
Thanks for having me, Frank.